Okay, well, welcome everyone to this session on the Heat Smart Capital Region campaign, on Aztech Geothermal, and on National Grid, and how we work together to promote heat pumps. I would ask that all of you keep your computers muted while we do the presentation, and then we'll have time once we've completed the formal presentation to be able to take your questions and answer them. So thank you all for joining us. My name is Todd Fabozzi. I'm the Director of Sustainability for the Capital Region Planning Commission. And my role also is to direct the Heat Smart Capital Region campaign. And I want to talk about the campaign as an introduction to this, and then I'll be turning it over to John and to Jenny. So let me start by just giving you some background about the Heat Smart Capital Region campaign. So the Capital District Regional Planning Commission got a grant from NYSERDA to promote heat pumps, a program that NYSERDA has in place now for several years, and we're about 1.5 years into this program to promote heat pump technology, to promote a transition away from heating and cooling with fossil fuels, and to try to electrify our building stock, which is a significant portion of our greenhouse gas emissions in the state. And so for us to be able to achieve our state climate goals, we need to start electrifying our heating and cooling. So this is one of a number of efforts to try to promote this technology. So the role of our campaign is to talk about heat pumps, to be able to just basically educate the public about the benefits, about the technology, and how it can help them and how it can help the state. And so in order to do that, the campaign also is charged with trying to promote growing the heat pump market by promoting companies that install heat pumps. And so our role is also to then bring together companies and get them to join in on our campaign and our promotional efforts. So the slide that you see in front of you is the 8-county Capital District region. And this is the region in which we are running this current campaign. So as I noted, we're about 1.5 years into the campaign. We have about another 1.5 years to go where we'll be doing this, at least under this particular grant. We'll see what opportunities exist going forward to continue promoting this technology. And so one of the challenges, of course, with this large area is to be able to make sure that we have installers as part of our campaign that can service customers in this whole area and cover the different technologies that we're looking at promoting. And so we have, as part of this campaign, put out a request for proposals for installers who want to be part of this campaign. We've interviewed those installers, and we have selected a team of installers to cover this area that become part of our promotional efforts. Next slide, John. So one of the ways in which we are able to promote the campaign is by using a website portal where we direct potential customers and people just interested in learning about heat pumps to be able to go to the heatsmartcapitalregion.com website. So this website allows you to, first of all, just learn about heat pumps. There's various instructional videos and links and descriptions about heat pump technology. But there's also then the ability to enroll, and that is to be able to put your information in. There's no charge, there's no commitment to doing this. It's a way for you to be able to connect to the installers that are part of our team, and to connect to us if you just want to simply learn more, but to connect to the installer. So you would be putting in your contact information in the enrollment tab. You would be selecting basically the geography that you're a part of, and also the installers you would want to hear from. And then the installers would be notified of your interest. They would reach out to you, and they would talk to you about your own building, your own home or business, and what it is that they could do to help you in considering installing a heat pump in your home to heat or cool your building. And again, there's no commitment to this, so we encourage anyone who's interested in learning more about heat pumps and in talking to our installer team to be able to enroll in our program through the website. We'd also promote other events and other kinds of opportunities through the website. But we also, of course, if you're going to enroll and choose installers, you need to learn something about the installer team. So next slide, John. So this is our installer team that we've chosen to promote as part of our campaign. So we have a series of companies. So we have a company, Global Dwelling, that does energy efficiency. And that is just to be able to make sure your building envelope is tight. And so that's one option as part of our campaign, is just simple energy efficiency. And they don't install heat pumps, but they're kind of the precursor to just making sure your building is well insulated and well air sealed. And again, no requirements here. These are options for anybody. Then we also have a group of companies that install air source heat pumps. So we have Hot Water Solutions, Ridgeline Heating and Cooling, and Choice Heating and Cooling, and Aztech Geothermal, and the Radiance Store. So all in that central circle, all of those companies do install air source heat pumps and air source hot water heaters. But then we also have the option for geothermal, so ground source heat pumps. And so we have Choice and Aztech and Dandelion that all do geothermal systems, and in some cases as well. So Choice and Aztech do both. Dandelion just does geothermal. And so this is our team. And again, these are all vetted companies who are very knowledgeable in this and high level expertise and experience in doing this. And again, no commitment to reach out to any of them. So the website will then show you basically what areas they cover geographically and what technologies they cover, and you can connect with any of them through our portal. I should also point out that the Capital District Regional Planning Commission also promotes other programs beyond just this Heat Smart campaign, and one of them is the Clean Energy Communities program. And that is a program in which we work with local governments to be able to become energy efficient and to convert to renewable energy. And one of the aspects of that program is that a local government can get a grant for promoting a local Heat Smart campaign. And in our region, they can just simply join on to our campaign, promote a local micro campaign just for their community. And if they get a certain number of installs based on the population of that community, they qualify for a grant from NYSERDA for doing so. So anybody who's interested, reach out to me if you think that your community may be interested in promoting heat pumps and wanting to join in on our campaign with a local micro campaign. And we can talk to you about the opportunities for that. It goes beyond just heat pumps. If your community wants to get involved with other initiatives, there are other grants for those initiatives as well, but also just a standalone grant for promoting a Heat Smart campaign. And we've basically laid the groundwork for that by having you be able to just join in on our campaign. So I encourage you to reach out to me if you want more information about that. So next slide, John. And this is my contact information, and I believe the slides will be available, but if you want to jot that down now, the key things to note, of course, are the email address and the phone number, but also heatsmartcapitalregion.com as the website to be able to check. And the contact information and email are on that website as well. So if you just go to heatsmartcapitalregion.com, you can get all the information I just talked about. So now I'd like to turn it over to John Ciovacco from Aztech Geothermal, who is one of the companies on our campaign. And John is a widely recognized expert on this technology, and he'll talk to you about in much more detail about the specifics of his own company, but also the technology itself. So I'll turn over to you, John.
All right. Can everybody hear me? Somebody nod. There you go. Great. You never know. It's one of those mornings. So my company is one of the Heat Smart Capital Region companies. And so we've done a bunch of mostly ground source systems, but we do some air source, and I know lots about air source. And so I can certainly address those questions as well. We do all manner of things. Mostly we do residential, and on big buildings, we do a lot of consulting, and we do a lot of repair, unfortunately, on some legacy systems. But the NYSERDA programs are so much better now than they used to be that the chance of a system not going in properly is very, very small, which is terrific. But that wasn't true for some years. So everything's better. I'm going to race through some concepts that that all deserve more time. So, and I don't look at the chat. I'm bad at that. So we'll address questions at the end. And we also have Jenny Cross from National Grid at the end. So as a lot of folks that are on here probably know, we have a new climate law, the CLCPA for short. And I just want to highlight some aspects about this climate law that heat pumps contribute the most to. Oddly, you don't think of a heat pump necessarily as an energy efficiency thing, but it's arguably the most effective. If we think of energy efficiency as a reduction in energy in a building, for instance, and we have goals, we have this 185 trillion BTUs that we're going to try to save from buildings that they don't end up needing. Well, a heat pump is an air source heat pump is about 65% reduction, 60 to 65% reduction in the amount of energy that needs to come to that building for heating and cooling. And then a ground source is up to 85% reduction. And those seem kind of like crazy numbers, but we're going from efficiencies that are in the, say, 85, 90, kind of area with combustion systems to heat pump systems, which are using electricity to leverage the energy. So we use electricity to run these things, but they're really using that electricity to leverage renewable energy, renewable thermal, either from the air or the ground. So the other obvious thing besides their energy efficiency chops is that it's a 40% reduction in greenhouse gas by 2030. We're obviously, if we're taking combustion out of buildings, we are reducing greenhouse gases, and you'll see that there's another aspect of that in 2050 as the CLCPA goes, the 85% net reduction. The thing that I think people don't necessarily think about, or it's less intuitive, is that if you install an electric-based heat pump system in place of a combustion system, if you're hooked up to National Grid, if you're in a lot of upstate or NYSEG, you have pretty low carbon electricity anyway. Upstate New York is particularly good, but there's some, and downstate less so. But as the grid gets cleaner, by 2040, we have 100% clean electricity. Your heat pump actually has gotten better without doing anything, just because it's based on electricity. Upstate New York, though, we have a very clean grid. It's always an environmental win to go to a heat pump system versus either air source or ground source in terms of the climate impact. This is kind of an outgrowth of the CLCPA process. We have a Climate Action Council. That Climate Action Council is inundated with information, and part of this information came from energy and environment and economics, and sometimes called the E3. It's the E3 Decarbonization Pathways Study. But what does this show us? This shows us, as a projection, that this is 2020 when they did the study, and 2050 is over there. Hang on one second. I love the laser pointer. Isn't that slick? 2050 is the sort of the goal out there. This is sales of percent of space heating sales, so equipment sales. So right now, electric resistance has a bit of the game. Heat pumps relatively small. Natural gas pretty big, and then some other fuels up here. What they're saying is, we go forward by 2050, it'll be almost all heat pumps. That's basically kind of the projection. So right now, you see that this Heat Smart program, and there's a few installers. Ultimately, all HVAC companies will be heat pump installers. That's what will happen unless there's some significant shift in technology between now and then, which is possible, but there's really nothing on the horizon. So just recognize, if you don't have a heat pump now, and you think you might live to 2050, you're going to have a heat pump. We're going to get you eventually. How does it work? Comes up a lot. We will not have time to describe this adequately. So I'm going to describe it inadequately and very quickly with a lot of arrows and complicated things. So we have low temperature energy source over here. And so it comes in and it's going to cause this refrigerant, which sounds kind of scary. this refrigerant in the heat pump to evaporate. It's very low pressure and it evaporates at a very low temperature. So mild temperatures like outside air or the ground, the temperature in the ground, when they go over the evaporator, they cause that refrigerant to evaporate. When it evaporates, this surface gets colder and it makes the air or the water colder. So it's energy. So Donald, can you mute yours? Yep, that would be great. So now the energy is in the refrigerant. How that actually happens is we don't have time for, but let's just say it is. But it's not the temperature we want. It's the temperature of the cold outside air, or the temperature of the ground. It's still not really warm enough to heat. So what do? We compress that gas. When you compress a gas, it gets hot. Is a direct relationship. As pressure increases, temperature increases in a gas. So on the other side of this, so we might go in at like 40 degrees or so here, maybe quite a bit lower than that. We're going to come out this other side after we compress that gas in the compressor, which uses electricity. That's Q2. That's the energy we pay for. We're leveraging this energy with the energy we pay for. This is about 160 oftentimes, depending on how the heat pump's running. And then it's going to cool down a little, but then it's going to be generally about 120 is a common temperature for this. That 120, that 160, really most of that came from the ground and a ground source. So that's 3 units of renewable energy, plus that electricity that we use to make it hot. But we didn't heat it with electricity like a toaster. We just used that electricity to leverage by compressing. And then we get 4 units of energy on the outside into the building, 3 of those from the ground in a ground source case. And if this was air source, this is more like 1 and 1 or a little bit more than 1 for the outside. So you're going to end up with 2 times the amount of energy. So it's 2 times more efficient, you might say, than an electric baseboard system. So that, and that's all called the coefficient of performance. It's where we have this ratio between how much we put into the building versus how much we have to input to get it. And that ends up, it can be expressed in things like 300 or 400% efficient. But in reality, from a science standpoint, something's like you can't try 110%. 100% is all you got. But we cheat by getting this renewable source and leveraging what we pay for. So if we just look at what we pay for, we could argue it is 200, 300, 400% efficient. What are our options if we want to electrify? So we have electric resistance. Electric resistance is not awesome. It uses a lot of electricity to get energy. We're making energy directly from that electricity. That's a COP of 1, also known as 100% efficient, just to confuse everyone. But it's expensive. And I think everybody has a sense of that. Air source heat pumps we're leveraging. We're starting to leverage with these heat pumps. And we have the ones to make hot water. We have ones for space heating. We got big ones for big buildings, sometimes called VRF in that form. And those are we're leveraging. So for 1 unit of electricity, we're getting some extra bang for the buck. Those tend to be in the operating range more like oil and propane. If oil and propane are expensive and electricity is pretty stable, they can be a savings. If oil and propane are cheap, they're kind of on the cusp, but they're kind of in that realm. They're generally a savings on oil and propane, but they're more like it from an operating cost standpoint. If we want to get to the prices like natural gas, we have to go to something that's quite a bit heavier lift. We have to put some permanent energy infrastructure with our building, our home. And that's with the ground source or some types of water source heat pump arrangements. That's when we start to leverage and we get into those COPs of 3 to 5 or so. And the system behind me, for instance, operates at a COP of about 5. And so we're leveraging that energy from the ground, and that's going to be more like the cost of natural gas to operate, but it's a big upfront expense to put it in. And there are some incentives, and we'll talk about those, and Jenny will talk about those too. Here's just a little bit more specifics. I have my assumptions here. I'll give this out. The assumptions are ever changing. What's the price of oil? What's the price of propane? What's the price of natural gas? These things move all the time. But at this point in time, with those assumptions, ground source and natural gas are pretty similar from an operating cost standpoint. Actually, natural gas is generally lower than even a geothermal heat pump, but it's, at least if you want to get close, that's your shot. Air source, really good compared to electric resistance, which is up here, but kind of, and often a savings over oil and propane, but doesn't really touch natural gas from a BTU output standpoint in upstate New York with this pricing assumption. So just to have you know that electrifying, I have a lot of folks that electrify that know that, you know, they might put an air source heat pump in a natural gas home because that's a choice they make and they feel like they can afford to do that. But at the same time, you just have to recognize that just because we electrify and it's good for the environment, there's a cost to doing that. And we're always trying to manage that in our business and certainly on a policy level. And if we go to that, almost everyone has a heat pump, the volumes will get such that this will all start to come down quite a bit. But right now it's still a bit of a niche technology. So those are our electric options if you want them. One of the big challenges, and many of you listening know this, is that distribution systems in people's homes, especially and in commercial buildings, are with hot water. They're with steam. They're with hot water. They're with something that a heat pump doesn't do that well. Heat pumps like to get up to maybe about 120 comfortably. We can see 140 or 150 occasionally, but not efficiently. So we need more surface area. So this is a high efficiency baseboard. It has more surface area than a typical baseboard, which would be about half the surface area. So a lower temperature source can be put in. If you have traditional baseboard, you might need to augment with some of this or replace with some of this. Or you can add in radiant panels, something with more surface area so you can handle that. You can have output with that lower temperature. Radiant floors are a good choice, lots of surface area. Ductless systems, we typically think of those as mini split systems that have a refrigerant coil, but they also can have a water coil. So this could be delivered by refrigerant or by water. So a heat pump that can make water warm can also be used in a ductless application. Ground source heat pumps tend to be central systems. That's the most common, and central ductwork systems are the most common, but we also have systems that can make hot water. Air source systems, you certainly have this option here, the ductless system, most popular, but they also have central systems, of course, too, that can go through a central ductwork system. They also have air source that makes hot water. It's more rare and starts to fall off the efficiency scale even more. Not a new technology. This is from 1948, and it talks about the Miracula. And the Miracula was miraculously huge, took up most of your basement. But it was cheap. It was a couple $1,000 and then $1,000 to install. So if you call us up, or if you have already, you know that that is not the current pricing, but it's fun to look at. So how does the ground source system work? It's really the stored thermal energy in the ground ends up being, once you get about 20 or 30 feet down, ends up being about the average air temperature of a particular location. So it's about 52 degrees in upstate New York. It's about 77 degrees in Miami. So it's just a question of, you know, how much sun is hitting and absorbing over time, and weather effects have an effect. But once we get below, it's kind of like Howe's Cave is 52 degrees all the time. That's interesting. You know, that's a source of energy that we can use in the middle of the winter when the snow is covering it. It's basically a storage. So how do we access that storage? The most common ways are we put pipes in the ground that access that, and we run a water and antifreeze solution through those pipes. The horizontal systems have larger surface area. They tend to be about 6 feet in depth over a large area, and bring that thermal energy into the house. Vertical systems don't really look like this, and I probably should change that picture, but I've used it for years. They're really usually 1 or 2 boreholes for a house, more for a commercial building. And they're really in one borehole. They're not this kind of like big loopy thing here. We just make one, and then the pipe goes up and down in that same borehole. Those are hundreds of feet. So my system has relatively shallow ones here. So 250 foot, but it's more common that I'd have a 450 foot borehole for a house, or 300 foot boreholes would be common depths. Pond systems, we probably have about 14 pond systems where we drop polyethylene pipe typically to the bottom of a pond. So it's like a horizontal system, but we're getting the exchange from the water in the bottom of a pond. And those are all frozen over right now, and they're heating their house with those. But again, we won't go into too many details. There's direct exchange, which is not a water-based system. The refrigerant from the heat pump itself actually goes into the ground and makes a direct exchange. That uses copper piping. It tends to be in this kind of like node and out at angles. So it has a very small footprint, and that's an advantage. And these tend to be shallower. It has a lot of advantages. The disadvantage that's recognized is that it's copper pipe, and copper pipe versus this is polyethylene pipe, very rugged polyethylene pipe in the water-based systems is kind of forever technology. This is less forever. And if you have a problem with it, you pretty much abandon it in place. But it does work. And there's I think there's a company in Westchester that does it. I don't even think you'd be able to get it in this area. So what does that look like in a real system? So if I have the loops are outside, they usually go through the basement foundation. They make their thermal exchange with the refrigerant here. We make it hot in the winter with that compressor, and then that hot gas goes to the condenser coil here. And so the air from your house comes and we heat it up. It's reversible as well, which is this thing here. So it's also an air conditioning system. And that's one of the nice features of heat pump systems is they are your heater and your air conditioner in most cases. So ductless mini splits, kind of a super common application. They go down to now -22, some of them. So I have to update that too. Jeez, technology just goes faster than I do, I guess. When we have that happening, if it's really cold outside, the only thing we know is this outside thing is colder than outside. It has to be. If it's going to get energy to move into that refrigerant, if it's 0 out and this thing is operating, and it is, all I know is it's less than 0 after it gets through that thing, because I've taken thermal energy out of that 0-degree air enough to compress that gas and make it warm when it goes inside. The colder it is outside, though, the more compression I need to do to make it comfortable inside. And as a result, the efficiencies drop. But they have variable speed so that when it's mild out, they run super efficiently. And when it's cold out, they're much less efficient. But the average of those ends up being a pretty good number. And in the summertime, if we're cooling down, the only thing we know is this has to be hotter than the outside air to get energy to want to move. So whenever you see, like if you see an air source heat pump on a super cold day and it's running, the only thing we know is it's colder here. They have defrost cycles too, which can influence their operation and also their efficiency, but they hang on great. They're kind of shocking how effective they can be. This is kind of what they look like in real life. So you've got that outdoor unit here that's sort of through that door. The refrigerant line comes in, then you'd have typically a distribution head, but there are lots of options here. You can have an air handler. You can have a cassette that's maybe in a drop ceiling, so you only see this top part. You can have this guy that's hidden again in a drop ceiling kind of area and then ducted short. You can have console units. So there's lots of product forms that these can take. So if you see these mini split heads and you say, I don't want that wall wart in my house, you have other options that you could look into. I get asked, well, how much electricity? And if electric resistance is, if we're going to make 100% clean electricity in the grid, electric resistance is cheap. Let's just install electric baseboard or put in an electric furnace. Well, if I want to make that renewable, I need a lot of panels. I need a lot of renewable electricity to do that. So I have this, if I replace 1,000 gallons of oil, how much electric to then make it renewable, how many solar panels would I need? And this is just with some assumptions. My assumptions are down here, which is something we'll share. You'll see an air source heat pump. It's more expensive than installing electric baseboard for sure. It electrifies, but this does it a whole lot better. So we need a lot less electricity to run this system. And then if we go to ground source, we need even fewer. And one of the things that's kind of cool about that is that if we're going to go to 100% clean electricity, now the grid has to do that. It has to be supplied to us in many cases. And if we do that, we want as little additional capacity to be built as possible to keep the prices of that electricity low. So we want to always move towards more efficient ways to do that. And heat pumps, you can see why they're sort of the choice for electrification, and we're not doing just simple electric resistance. I'm not going to go through these in detail. These two are electric resistance technologies. One's a tank, which is a super, common. Many of you might have it. This is one that has elements in it. So we're just heating it up on demand. Those will dim your lights when those things go on. You need a lot of electricity, rush in to get that to work on the fly. So if you want a recommendation, I'd go with this with electric resistance. This saves space, but probably takes the neighborhood's electricity down. Air source heat pumps, so that's in your basement, and it's using your basement air. Oftentimes has to be in a big enough space. It's going to make your basement a little cooler. That's kind of good in the summer. Does a little bit of dehumidification. Again, that can be good in a moist basement, but just recognize it makes some noise and it does make that room a bit colder. Then we have, and these are just more elaborate. This is the system I have in my house, but it's similar to this. We preheat using the geothermal system into this tank, and then that's the feeder tank for a finishing tank. So this is a way to get better leverage. So we get a little bit more efficiency out of that. We can go to a dedicated geothermal heat pump that just makes hot water. That's much more efficient, but much more expensive, but can be done. And then I have solar hot water here. I have to say, people that have it, it's installed, I think, appreciate it. I've had good experiences with it. It's less common. The incentives have gone down for it. And in general, I see people opting for renewable electricity if they were going to take up some roof space rather than go for the domestic hot water and adding some additional complication. This is a cool one. This is one that we have that has a geothermal heat exchanger that also works with the solar hot water. But I have to say it's more of a science experiment than it was really cost effective. So don't ask us to do it again. I'm not going to go through these because Jenny will. This is some of the incentives that are out there. And then I'm just showing people this as a takeaway. This has some comparisons between ground source and air source, some of the installation costs and operating cost comparisons, kind of broad brush general stuff, but I find that people are interested in this type of information. All right. I am going to switch over to Jenny. If she can unmute herself and
I believe I did. Can you hear me?
I can. Yep.
Okay.
And let me see, get you up. Boom. There you go.
Perfect. Thank you. So my name is Jenny Cross. I am with National Grid and the program manager for our New York State Clean Heat statewide heat pump program. You want to go to the next slide for me, please? Thank you. So I think, did we skip a slide? Well, either way, that's okay. So we offer, there's the statewide heat pump program has, it's a statewide offering. We work with all of the electric utilities across New York State, being NYSEG, RG&E, Central Hudson, Orange and Rockland, and Con Edison. So wherever you are throughout the state, you should be able to find this program for as an electric customer. We do offer incentives on all of the heat pump technology that John was running over. So air source heat pumps from a midi split to a centrally ducted system. You did go back to the Heat Smart Capital Region presentation.
Yeah, I think I'm going to try to find. I think I have your old
slide deck.
Yeah,
not a problem.
So just keep going, and I'll get it up for you.
Yep. And then ground source heat pump technology, we have incentives for, as well as heat pump water heaters. And it is across all building sectors. So whether you're a residential homeowner, multifamily buildings, small commercial, large commercial, a lot of those fall under what we call a prescriptive category. So this is basically the information I am covering here. If it is a large commercial building, it would generally go through a custom path, but this is unique for at least National Grid to have one incentive program open to all building sectors. So that's an important aspect for us to share. You can go on to the next slide, and that is pretty much where we were before. So to start, if you guys are interested in looking for an incentive, we do require contractors be participating contractors with New York State Clean Heat. A lot of the times these contractors work with multiple utilities, but they can work with individual utilities as well. You can find these contractors listed for National Grid on our landing page with RISE. So RISE Engineering processes these applications, and they're a great resource. If anyone has questions, contact myself at National Grid or RISE. And then NYSERDA also has a large role in this statewide effort. And they do have a statewide landing page to identify contractors as well, along with other resources that you could find on that page. We can go to the next slide. So this is an overview of the application. National Grid and NYSEG RG&E, a lot of our territories overlap. So we did have the opportunity to co-brand an application. Our incentive offerings are the same for each measure. So if you got a heat pump water heater and an air source heat pump, both of those incentive dollar offerings are the same. This application will look a bit different. NYSEG and RG&E has transferred over to an online application portal. So they're actually no longer going to be listed on this application, but it's still nice to note that the incentives are the same across upstate New York. And National Grid is also looking to move to an online portal as well, but we are not there yet. So we have an online application that's form fillable. You can see the contact information for RISE in the central how to apply area. So there's their website and phone number there too if you ever had questions. And we can go to the next slide. And this here gets into a lot of your existing project information and the equipment that you select. So we're doing, we're collecting a lot of information about what exists so we can, sort of track this throughout the state of what types of existing customers are converting, or are a lot of these going into new construction, to gauge it, to make sure we're on track to meet the state's goals. This will give us information, and then it kind of gets into a little bit other details, such as building type and just other information that help us do energy savings calculations internally that customers don't need to worry about, but that is why we collect all of that information there. And we can go to the next slide. So this is all on the application as well. I blew up the tables. It's just easier to see. It's, if I had all of these tables together, you wouldn't be able to read it. So I broke this out into an air source heat pump category. We have different incentive levels for a home that's doing a partial load heating versus a home that's doing a full load heating application. So a lot of the times, if you're just looking to heat and cool an attic space or an addition in a sunroom or something, you would end up going with that partial load mini split heat pump. Then when you get into installing either multiple mini splits if needed or a centrally ducted air source heat pump, a lot of times this will cover your full home building heating load, which you can see that John's highlighting there, the 90 to 100% of your heating load is covered through this technology. And the technology is designed to be reliable through upstate New York winters. They are cold climate air source heat pumps. So, that is the intention. They do work all year round as both heating and cooling. But I know a lot of people still have different reservations and prefer to keep their backup system in. It's not required to remove it. We do ask on the application just so, again, we have a sense of what the market is doing out there. But the technology itself is reliable. So we can go on to the next slide. And this shows both our ground source heat pump and the custom incentives. So the ground source heat pump, generally, if you're investing to put that in, it will cover your whole home's building load. And as John mentioned before, this also duplicates as a cooling system. So this, these air source heat pumps and ground source heat pumps can replace two units in your home with one. So that is certainly a nice perk. And then getting into larger systems, that's when we fall into the custom incentive category. A lot of times these would be for commercial applications. You can see VRF, which is typically used in a multifamily system. It's a air source heat pump. And then other systems that once you go over a certain threshold of capacity, so if you're over a 300,000 BTUH, is sort of what kicks this category into place. It is open for residential, but most likely these will be commercial buildings, and we do a lot more analysis to determine energy savings here. So this would be what we call a custom incentive, and it's based on energy savings, whereas the others are based on the equipment themselves. We can go on to the next slide. It's the last one showing the technology, and this gets into your heat pump water heater options. So you have your heat pump water heater tank that John was showing. Again, we have a commercial option that's larger that would fall into a custom category. And then you get into your ground source heat pump de-superheater or the water to water heat pump. So really trying to make sure we capture all of this technology. And for those customers that are looking to electrify their homes with both an air source or ground source heat pump and a heat pump water heater, there's a bonus here to help, encourage that behavior, and of course, to help with the cost, because that is certainly a barrier right now in the market. And that's what all of these incentives are truly intended to do, is to help customers with the cost of this equipment and investing for long-term savings. So we can go to the next slide. This does provide a breakdown of incentives. I would say these are more contractor-friendly readable than customer-friendly readable. As you can see, the only straightforward one, in my opinion, is category 1, which is $500 per outdoor condenser unit. We do offer contractor rewards, what we call them, from these incentives. As I said, we require them to be listed as a participating contractor, which comes with different trainings that they have to partake in, as well as a lot of paperwork to provide us to get the incentive. So there is a little reward for them for helping us reach our goals here. Once you get into the for example, category 2, full load air source heat pump, 1,000 per 10,000 BTUH of maximum heating capacity at NEAP 5 degrees. I would encourage you to chat with your contractor about this and see what this means, or feel free to contact myself or Rise, because we do have examples that we can show, what this means and how we get the incentive and what that incentive dollar would mean for the customer. So again, I wanted to share this, but more would encourage customers to chat with contractors or your utility representative regarding what your incentive would be. We can go on to the next slide.
Yeah, let me just give a little perspective just quickly.
Sure, yeah.
So if you just have partial load, so you just maybe do your great room and you just have one mini split head, you get $500 for that, but your contractor might take 100 out of it, so it might only really flow through to be 400. If you do your whole house in air source heat pump, and let's say you have a 4-ton system, this is about a ton. So you'd have $4,000 is kind of wouldn't be uncommon for full load air source. that same size system would be $6,000 in ground source. So you, just to give some perspective that, you know, if you just go partial, it's how many outdoor units that you have. If you do your full load, a 4-ton system is kind of a, you know, 4 or 5 ton system. So it's going to be 5,000 or, you know, 4 or 5,000 here, and about 6,000 or 7,500 would be common in those 2 areas. And then these guys are very straightforward. They're just, you know, if you get a heat pump water heater, it's kind of cool. You get $700. And the contractor gets nothing. So, you know, you get all of that. So it's not too bad.
I chime in also and just point out, John, when you have a customer, as an example, they don't have to go and figure this out themselves, right? You figure that out for them and you file this for them. Is that correct?
We do. Yeah, we absolutely do it all. They need to sign it, and we like them to understand it if they, to the extent that they choose to. They certainly, there's a requirement that the customer, aside from the contractor incentive, that the customer has to get this. You know, this isn't something that your contractor can just sort of like squirrel away. So, and you definitely, if you have a contractor that doesn't participate, you should ask them to participate. So if you have somebody that you like and they don't currently, you know, they want to install an air source heat pump, you like them, but they don't participate, say, you know, there's this thing that you should do. And we want more contractors to get involved in these programs for sure.
And all the contractors on our campaign participate, by the way.
Absolutely.
Yeah. And all of that is certainly good information. We would love to have contractors participate. So if you're talking with somebody and you're unsure or you don't see them on the list, I'm happy to help them, you know, become a participating contractor, get them the paperwork required, and get them signed up. I did include all of the other utilities that I mentioned before on this page, just as a reminder that we all are participating in this program. So check out their websites. It's the same. You would use a participating contractor. The whole structure of the program is the same. Just the way you apply would be through a different utility. And incentives would likely vary. Con Edison down in New York City has higher incentives. These are higher costs generally to install them. So it sort of aligns with where you are throughout the state. But take a look at these if you're in another utility besides National Grid. And we can go on to the next slide, which is just to let you know, this is the statewide branding, New York State Clean Heat. So as we continue to roll out this program and try to gain that traction of a statewide, you'll see this logo, usually accompanied with a utility logo as well, but that will come out, and we have a statewide landing page that is directed for customers to have resources to help educate on the technology. You can compare technology types, find a solution that best fits your home. You know, we've gone over several solutions you can have and find out what works with you, connect you to a Heat Smart community, participating contractor, and all of this will be out, you know, in the next few weeks, really, April. And that's the statewide landing page there where you can take a look and learn more on how to participate. And I think there might be one more page. Yep. So that's my contact information along with Rise. And we're both happy to help answer any questions or work with contractors to get them signed up as participating. And I will leave it there. Thank you.
Okay, thank you, Jenny. So I don't see any questions in the chat. If anyone has questions and they'd like to enter them in the chat, we can ask those. I'll read them. Or if you would like to use the raise your hand icon, if you have a question, then I can call on you so we don't talk at once. And you can unmute yourself and go ahead and ask a question. So are there any questions for any of the panelists?
I did have a private question that I'm answering about where they can find a contractor. So feel free to look at Rise's landing page. If you end up on National Grid, there's a link to Rise, so you can start either there, either place. But I will get the exact link and post that.
Okay, great. So we've got a couple questions now. So hold on, Daniel, I see your hand raised, but let me just ask a couple that are in the chat first, and then we'll get to you. So the first one is, How long does a ground source heat pump last?
That's me. The ground loop is effectively forever. I know that's not an official word, but it's polyethylene piping that's buried in the ground. The only thing that really attacks it is ultraviolet light, and buried in the ground takes care of that. We replace them sometimes when people put a shovel through it, but it's the same basic pipe that's used in a lot of municipal water systems and in natural gas systems, actually. So the inside part is a heat pump, and it's a mechanical piece of equipment. In the technical resource manual that's used, its 25-year life is kind of the effective useful life. We're replacing them usually in the 20 to 25 or 30-year kind of time frame. It doesn't get too hot or too cold, really, and they tend to be pretty hardy.
Okay, thanks. This one's for you, Jenny. The question: are these incentives sunsetted or limited in time frame?
Sorry, I hit mute. This program has funding through 2025, so no chance of running out of funding anytime soon.
Okay. Daniel, you can unmute yourself and ask your question.
Yeah, I'm actually, I see the same question is up in the chats. I'm thinking, I'm on the Sustainability Advisory Committee for Albany, and, we've got like, what, 20,000 houses in downtown Albany, probably more than that have radiators. And I've had a few conversations with companies. I guess there are a couple of German manufacturers, doing air to water for the heat pumps for the purpose of home heating. And I'm just wondering if you guys have thoughts about that. Is the sunk cost of the distribution, the heat distribution technology sitting in those houses worth preserving, or should we just rip out all the radiators and put in multi-splits, mini splits?
John, take that one. You don't seem to
John,
be.
you're mute.
Double muted. It's a very common question and a big problem. I would say that of the homes in the Capital District and kind of surrounding area, maybe 65 to 70% plus don't have a central ducted system. They have these hot water based systems, radiators or baseboard water systems. So it's a longer story. Yeah, you can make lots of things work if you really try hard. So for instance, you can put in more high surface area baseboard and or these radiant panels that I showed a picture of. The problem with that is hydronics are kind of expensive to install or augment or replace. And then by the time you do that, you have about the same expense as maybe it was to install central ductwork, which would have gotten you air conditioning. So the problem with some of the conversions are tough. You can't put their heat pumps. There aren't heat pumps that are commercially available or really even research available that make water hot enough at a reasonable efficiency to be a drop-in replacement to a boiler. A boiler tends to run at 160 to 180 is the kind of common swing in hot water. Steam is steam. We don't make steam with heat pumps. You can. It's experimental and it's inefficient. But for all practical purposes, we oftentimes look at ductless solutions or we install ductwork. I've done a couple of hydronic upgrades, but again, it's really just someone that's really dedicated to that baseboard water system, really hates a forced air system, but then they don't get air conditioning with that. And then
it's just not really that expensive to rip out all the radiators, so why not just do it? Is that what you would say?
No, it's really expensive to rip out all the radiators and put something else in. It's a conundrum. No, it's a conundrum for sure. It'll I remember when Dandelion first started out, they said, we're just going to do houses with existing ductwork. And then they realized, crap, that's a big market, but we're missing a big piece of the market. And they and others are desperate to try to find.
Yeah. So I don't want to be a hog, but I'm just going to make one more suggestion. Like, couldn't it be possible? Like, imagine a system for a downtown townhouse in Albany where you had solar panels on the roof, not wired to the grid, but just driving an air conditioner. You cool down the house as much as possible during the day, and then you do an air to water heat pump and supply the radiators in the winter. Like, isn't that like, if someone could make that work, wouldn't that be a good solution to this?
the problem with solutions like that is that they're lifestyle based. I mean, that's, if you don't have a thing where you go over it and you go, okay, I want it to be 72 and I don't want to have to think about that. And I don't want it to be overly complicated. We play around with folks talking about these things all the time. And at the end of the day, I have a few people that we've done science experiments to. They're pretty dependent on us because of that. And when I come into a science experiment, when it doesn't work and I have to fix it, you know, the programmable logic controller, it's like, yeah, I don't know what they were thinking when they did this. So we just have to be, as installers, I'm always trying to do something that's commercially available. And if I got hit by a bus, they could call the next guy on the list and be serviced. And, you know, you're talking about DC oriented, you know, things. We're going, you know, we're not going, you know, yeah, but that's, you've orphaned that person.
So John, when you say a ductless solution, just to be clear, an option for people with radiators right now could be to do ductless mini splits in which they're also getting air conditioning, and they could keep the radiator system in and just use that as a backup if needed.
Correct. Yep. Ductless solutions, though, are, I just want, you know, there's no heaven on earth on this one. Ductless solutions tend to, most of these older homes and buildings are cut up, what I call closed door rooms. They weren't made to, for mini splits. Mini splits, you know, this type of solution, I really need one of these in every room if I want to really control the temperature in that room. But what if you count the number of closed door rooms in your house and think about, okay, which ones do I want to heat and cool? And which ones do I want to kind of just be close? You end up with a lot of these heads. And then all of a sudden that's super expensive because you're just a lot of labor and a lot of equipment and a lot of things to maintain and replace. So we've done a number of folks where we do a ductless mini split quote, and then we end up putting central ductwork in because it's actually less expensive. As much as it sounds insane, it's less expensive than putting in 5 mini split heads or 7 mini split heads.
Okay, a couple more questions. I know we're running a little over, but it seems like we still have 30 participants on, so I'll read through some of these other questions. How much soil depth is needed for a ground source tubing?
So when we do a horizontal system, it's about 6 feet down, and then when we do a vertical, we go way down. If it's a pond, I like it to be 6 to 10 feet deep through a fair amount of it, and I like half an acre or more if it's a single family house. If it's a bigger building, it's more math. Okay.
There's a question here that says how about connecting ground source heat pump to an existing hot air system? And I guess that's really that's the ideal, right? You've got the ductwork and you can connect it.
Yeah, that's the most common thing to do. It's in the same footprint, basically, very, very similar to your furnace. You know, if this had a cover on it, you know, the thing behind me, it's called the water furnace. If I told you that was a propane or natural gas unit, you'd believe it. It's really in the same basic package.
Okay, here's one also for you, John. Are there efforts underway to make ground source heat pumps feasible in close-in residential areas in cities? For example, in my neighborhood, houses commonly are on 25 by 100-foot lots, narrow shared driveways or no driveways, no easy access to the backyard. So questions about that. And we've just in tight spaces in urban areas.
Yep, separate presentation, but I love the topic. You know, right now I'm looking at in Sheridan Hollow is over where the steam plant is for the Empire State Plaza. A number of you probably know about all that.
Looks like you hung up, John.
Humanity's doing some buildings. I'm trying to think a national grid community or district ground loop system, and then use that to start to look into another utility variant as opposed to delivering natural gas, and that might make those types of things more feasible. NYSERDA has a program out that just came out for people to group buildings together, and they'll pay up to $100,000 to do a feasibility study on how would you do that. So that very problem is really getting a lot of energy lately, and I'm actively engaged in that. Eversource in Boston has been given $10.5 million from their regulators to use their natural gas ratepayer money to install a 300-ton district system somewhere in the best Boston metropolitan area. So these types of things are very, very, very active in the dialogue and increasingly in practice. But we don't have great solutions in place just yet, but we're working on it.
Okay, here's one. I think I know the answer to this one. If you have a plot of land and want to use geothermal, what is the first step in your planning process? I would say contact John. But John, you want to take that one and just maybe elaborate on it?
We do. We can. I mean, we have such great access to satellite photos and things. We can usually get a sense about whether you need a vertical or a horizontal system. Vertical is we have a number of systems that are 10 feet from someone's foundation between the sidewalk and their house. As long as we can get the equipment in there, that's kind of the trick. I'm in downtown Schenectady. I'm right near Ellis Hospital, or in the city of Schenectady. Very tight lots, and I have some pictures from it too. The drill rig to get in my backyard was a trick, but it got there, and we could have done it in the front yard. I just didn't really want a circus out front. But if you think about it, it's the same basic technology. If you've ever been or seen when, say, a national grid or somebody goes and they replace all the natural gas piping in a neighborhood, it's kind of a similar process to that. It would be, you might put the ground loop somewhere else and then pipe over to it from there. But basically, if most vertical will work on most plots of land. It does get tough in dense urban environments. The brownstones in downtown Albany, those are tough in so many ways. There's so many permits and things you have to worry about. But if you have a house and it has a little bit of land around it, there's a good chance that we can make it happen.
Okay, and I think this is the last question, because there were a number on radiators. I think there was 5, 4 or so, but I think, and the one that Daniel asked out loud, so I think you covered that. This one says, can you provide an average cost for a residential air source hot water heater and how it compares to the $700 incentive? And also, what's the average kilowatt hour demand on this system?
Wow, average kilowatt hour demand, that's tough. It costs you about half as much to run as it would for an electric hot water heater. How's that? Because it's an efficiency of about 2 as opposed to efficiency of COP of 1. So it's going to take half of the energy is going to come from the air in your basement, and half of it is the electricity to run the little heat pump. So it depends. The water use is so different for different households, so it's hard to know. The expense to install, they're pretty expensive. Like the lowest cost one that you might find, say at Home Depot, is like $1,300, $1,400 cost. Before an installer buys it, we'll mark it up, bring it out to your house, and use labor to install. You really should put a pressure tank in most systems on there. You need a condensate place to put condensate, because it's gonna have condensate associated with it. So that adds some expense. The installed costs are typically in the $2,500 to $3,500 kind of range. Considerably more expensive than just an electric hot water heater, but really neat. They are much more efficient once you get them in. You just have to be aware they're going to make that room a little cold, and they're going to make a little bit of noise. They don't make a lot of noise. It's really very similar. If you've ever had a roll around dehumidifier, it's almost exactly that size refrigeration system that's on top of the water heater. And it'll make noise a lot like that would too. This makes, kind of a hum. It's not bad, but if it's right next to some place that used to be super quiet, you're going to notice it.
Okay, there's another one that came in. Can you give a ballpark amount to install, it says BHP vertical loop system to connect to an existing air duct for a 5-bedroom home?
I'm going to push that aside for 1 second because I remembered. There's a $300 tax credit on Energy Star rated heat pumps like this as well, federal tax credit. So add that to your list. Maybe Jenny, we should put a little asterisk on your application that people can look into that too. There's also a federal incentive for ground source heat pumps of 26% of the installed cost on top of the national grid incentive.
Just to clarify that question, because it was a typo. So it's ground source heat pump. So looking for a ballpark vertical loop system to connect to existing air ducts for a 5-bedroom home.
Chris Winkler has a booth at this show. You should go talk to him. Quoting prices out loud like this just gets me in trouble with my sales guy. I do have in my, and people can get this, we'll figure out how to get it to you, but I do have some basic, sort of ranges of installed cost here. It's expensive, but then after incentives is a big drop down. So I have my 35,000 to 50,000 here. There's lots of assumptions built into that range, but then you can also see there's also a big drop in price after that. So
okay, well, that's the last of the questions. So thank you everyone for joining this session. I urge you to visit the various booths, and we do have, for the Heat Smart Capital Region, we have a booth. For the Capital District Regional Planning Commission, we do have a booth. John Ciovacco and Aztech, they have a booth for this. Dandelion also has a booth. I'm not sure, Jenny, does National Grid have a separate booth?
We do not, but please feel free to contact me. I did send my email privately, but I can just throw out my email to the group. So if there's questions on incentives, feel free to reach out.
Okay, thank you, everyone.
All right. And do we have a thing later on today, a forum, Todd?
I think there's just an open discussion on heat pumps that anyone can ask questions and participate in. So
do you know what time that is?
I believe it's 2 o'clock.
Okay. I'll be there.
All right, great.
You can wrestle with more.